All right. So, activity 3.2, predicting theoretical probability using experimental probability. So list the sample space. So the sample space for this one, you'll either get a sun, you'll get a smiley face, or you'll get a star. Sorry for my sad looking star. But that will be your options, and so that is the sample space. Can you use the sample space to determine the probabilities of the spinner landing on each symbol? Explain why or why not. No, because the sample spaces I'm sorry, not the sample spaces. No, because the options aren't the same. I mean, if I look at this, the star should be the best. Be the best chanced. Because it's bigger. On which symbol does the spinner have the worst chance of landing? Oh, it's hard to say. Looks like the sun's smaller. Looks like this. It looks like the smiley face is a little bigger than the sun. So it looks like the sun looks like the worst. Okay. Then they say predict the probability of the spinner landing on each symbol. Well, I'm going to look here, and this looks like, so it looks like this would be 50% here, and looks like a little less than 50%. And so I think the star is going to be maybe 40%. And so I'm going to say 0.4, 40%, 4 out of 10. Okay. The smiley face, actually, I'll go with this one. The sun looks like it looks like a quarter. It looks like 0.25, 25%, or if out of 10, it would be 2.5 out of 10 as a fraction, 2.5. Okay. Then this one, it has to add up to 100. I know that from the last section. So 40 and 25 is 65. So that leaves 35. Yes. So 0.35 or 35% or 3.5 out of 10. Okay. And so that is me just predicting the probabilities of this. And now, based on this, it says predicting theoretical probability and then using experimental probability. So we started by guessing on theoretical probability because these are not equally likely to occur. Now we're going to probably do the experiment because I looked ahead to the next page. So I know we're going to do the experiment. But we're not going to do the experiment yet. Jonah and Melanie make the following predictions for the spinner landing on each symbol. Explain why each student is incorrect. Then want to pause, answer it, and then play this again. But I look at Jonah, and I look here and I see that 1/4 and 1/4 is 2/4, which is the same as a half. And so that's the same as 0.5. And I know 2/5 is the same as 0.4. And that only adds up to 0.9. And when I take all of these, it must add up to 1. And Jonah's predictions don't. Melanie, 1/3 plus 1/3 plus 1/3 is 1. Well, that's good, but we were just looking at that. There was no chance. We knew that the star, they're not the same. They don't have the same probabilities. So this is way wrong too. the outcomes are not equally likely. Okay. Is there a way to determine the exact probabilities of landing on each of the shapes? Explain your reasoning. Well, if I think back, it was like this, and then it was like this, and then it was like this. And so this was the star. This was the sun. Then this was the smiley face. And I'm looking at this, and I know that it's a circle. Okay. It is a circle spinner, or it forms a circle. Okay. Then I know from back when we started this school year, this crazy school year, that a circle has exactly 360 degrees. So we could measure how many degrees each sector was, and write that as a probability over 360 degrees. In fact, I think I might do that. 1 second. Welcome to where you don't have everything you need. All right, here's how this is going to go. I don't have a paper clip that I can find. So I am going to use this thingy right here. And I'm going to put this in the center. And then I'm going to spin it. And then wherever this part ends up, that's what I'm tallying. Did that make sense to you? Good. Okay. So that was a star. We'll move out of the way. You see how it's in the star section? So that was a star. So I'm giving that a tally. Oh, look at that. It almost fits. It almost fits. All right. Spin. Oh, tricky. I say star. Oops. Fail. Epic fail. That says star. Okay. So 2 for star. Nothing else. Okay. This has got to go quicker at some juncture. Star. 3. Star. 4. Sun. 5. Now we're good. I was worried. Bad spin. Bad spin. Unfair trial. Trial shouldn't count. That shows up a little better. Let me see how I can go. That was a smiley face. That was a smiley face. That was a sun. That was a star. 5, 6, 7, 8, 9. That was a smiley face. 10. Star. 11. Sun. 12. Star. 13. Uh-oh. Star. 14. Can never be easy. Smiley face, 16. Smiley face, 17. Smiley face, 18. Sun, 19. Star, 20. Star, I think, 21. Smiley face, 22. Sun, 23, smiley face, 24, star, 25, star, 26, sun, 27, star, 28, smiley face, 29, smiley face, 30, smiley face, 31, star, 32, star, 33, smiley face, 34, star, 35, star, 36, sun, 37, smiley face, 38, sun, 39, star, 40, 10 more, star, 41, smiley face, 42, star, 43, star, 44, sun, 45, star, 46, star, 47, smiley face, 48, sun, 49, and star, 50. Uh-oh. Uh-oh. I feel as though I've made a mistake. Look at what has occurred here, though. That's beautiful. That is a work of art. All right. 5, 10, 15. 15 out of 50, which is 0.3, which is 30%. Sorry. Sun, 10, 10 out of 50, 0.2, which is 20%. Star, 5, 10, 15, 20. It's got to be 25. I'm sorry. 25. I'm not spinning again. My spinner's broke. 25. 25 out of 50, 0.5 or 50%. Wow. Pretty impressive. Calculate the experimental probabilities using your data. Well, didn't we just do that up there? I think we did. So the smiley face was 0.3, 15 out of 50, or 30%. I got the 0.3 and 30% by multiplying these both by 2, so it'd be out of 100. The sun was 10 out of 50, which would be 20 out of 100, or 0.2 or 20%. Then the star was 25 out of 50, which would be 50 out of 100, which would be 0.5 or 50%. And then they add up to 100, so we're good to go. Compare the experimental probabilities with your predictions. Let's see here. On the previous broken page now, I have that we had 35% for the smiley face. Okay. I had 25% for the sun, and I had 40% for the star. So I would say they are pretty close, but they are not the same. Wah, wah, wah. Okay. And I was unable to measure the sections of this because now it's broken. And also I was unable to mention this because I strangely don't have a protractor here. I think my son has it. And so I might get back to y'all on the size of these to see what the actual theoretical probability would be for this particular experiment. Okay, so we're kind of working on in this section, in this lesson, in this part of this lesson, thinking about what theoretical probability would be and using experimental probability to help us understand what the theoretical probability is. Okay? And that is lesson 3.2.